Welcome back. Last time, for those of you who haven't been paying attention to the last several videos, I was talking about errors. I spent most of my time talking about topological errors. And remember, topology is about how features, especially in the vector data model, interact with each other. So there's three key things you need to remember about topology: connectedness, enclosure, and adjacency. So enclosure and adjacency, they're about polygons. Connectedness is generally about lines. So remember those things and how they apply to errors. Okay, so now we're down, getting towards the other. We're going to talk about two other errors, which maybe aren't errors, but they end up causing misperceptions on people's end. First one is ecological or ecological error. So what the heck is that? It's the belief that the characteristics of the group apply to all the individuals within the group. So here's an example. Now this map has a couple of issues with it, but first I'll talk about the ecological or ecological fallacy aspect of it. This is California, and these are the counties in California. And what's depicted here is the median income by county. So you can see that in County B, the median income is somewhere between $34,000 and $40,000. So generally people tend to believe when they see that the median income in this case is pretty low in this county, that everybody in that county is fairly poor. But really, there's bound to be people that are rich in that county and people that are really poor in that county. But since we report a single number or a single color for that single county, there's a tendency for you to think that everything inside of that county is the same. So that's what the ecological fallacy is about. It's about characteristics of the group, in this case the median, apply to all individuals within the group. So what the problem with this is, it's about the enumeration and how you're reporting the information, because the information that was collected originally had to have been individual incomes, and those would have been points. But the way this information is being reported is some type of enumeration or statistical summary of all of the information within that boundary. So that's where you get this ecological fallacy. You see it happening all the time. What's the second issue with this map? Well, the second issue is when you look at the data is numeric, it's income, so it's probably ratio data, which means you can do addition, subtraction, multiplication, and division on it. And generally when you have ratio data, the way you want to depict it on a map is not with different colors. Is there some reason that red should be associated with high income and this kind of light blue should be associated with low income? These colors send people's minds off, in terms of perception, into thinking different things. And so even though the colors are allowing you to see that they're kind of groups within this range, really when you have something that's using ratio data, you should depict it with a single color and either different brightnesses or different hues of that single color. So it should be a single color if it's ratio data. That's one of the things you learn about in mapping. Okay, what's this last error we're going to talk about? Modifiable areal unit error. Well, what the heck is that one? Here's a quote from Mark Twain. 3 kinds of lies: lies, damned lies, and statistics. Well, in this case, we can substitute modifiable areal unit problem for the word statistics. So what this is another one of those enumeration things where when you report the data at a unit higher than it's been collected, you can cause issues with what the results are and how it's interpreted. So it's a problem arising from imposition of artificial units, states, counties, things like that, for enumeration. So you have an enumeration unit, that's the extent in which the data are collected or enumerated or recorded, and the statistical properties can vary depending upon what that enumeration unit is, how big it is, and what the shape is. So there's two pieces to this modifiable areal unit problem. There's zone and scale pieces. So the zonal or the scale part of it is about correlation between variables. Generally, the larger the enumeration unit, the smaller the variation between the units. And that's going to be associated with something that we're going to call Tobler's first law in a couple weeks. And that says that basically things that are close to each other are more related than things that are further away. So if you use a large enumeration unit and say take a mean or a median or something like that, chances are you're going to get something that's close to the average over the entire study area. If you use smaller enumeration units, you might be catching the highs and the lows in the data. So bigger units, less variation. Here's an example. We've got a data set that has population, and these are the units here, and we have the number of unemployed. So these were all actually points that got enumerated over the polygon. There were 100 points inside here. There were 10 unemployed points inside here. So we enumerated that, summed it up, and said that's the total for that square. So if we just look at the percent unemployment according to the size, the scale of these zones, we're going to see that 10 people out of 100, 10% were unemployed. 5 people out of 300, 2% were unemployed. So look at the range of unemployment here. We have a low of 2% and a high of 25%. So based upon that size, that scale of enumeration unit, this is the variation that we get in unemployment rate. Let's change the unit size. Instead of having these smaller squares, let's go for rectangles. And now we add this up. 10 plus 20 plus 10 is 40 over 600, 7%. Do the likewise for this row and this row, and you see that the maximum and the minimum get much closer to each other. There's much less variation. So depending upon the size of your enumeration unit or the scale effect, you get different results. So some people attribute results to things that are associated with which enumeration unit and what scale you're using. Same thing works on shape. So let's take this same example. 10 people unemployed in this square out of 100. Let's draw some zones that have a different shape. Let's say we want to see something in this zone, and we add that up and divide it by the total, and we see that 7% of the people are unemployed in this zone, 15 in this zone, and 8 in this zone. So we've drawn these kind of strange shapes, and we get different percentages of unemployment. Now let's do different zones. And look at here. When we do different zones, we have 5% unemployed in this zone, 6 over here, and 16 over here. So if we were to attribute everything over here to the entire unit, we'd say, well, it's probably about 15% unemployment. But if we were to attribute that same space using this shape, we'd say 5% unemployment. So depending upon the shape of the enumeration units, you can get different answers. And this is the kind of thing that's associated with that word that you probably know and have heard. It's called gerrymandering. And so congressional districts generally get drawn in shapes such that the people that are going to be elected in those districts are the people that are associated with the party that maybe is drawing the shapes of those districts. So modifiable areal unit problem. There's scale and zonation effects. And ecological fallacy is the fallacy or the mistake or the error of associating the enumeration value to all of the units inside of that enumeration unit. So next time, you'll be happy to know that we're not going to have any more talk about errors. You made it through the error talk. Lots of talk about errors, lots of different ways. It's important to realize and understand that errors are important. Put garbage into the system, you're going to get garbage out of the system. So what will we do in the next module? We're going to talk about the vector data model. You already know about that at a high level. We'll go into a little bit more detail about how the vector data model works, how it's stored, and how it's used to join data that doesn't have spatial attributes associated with it to data that do have spatial attributes with it, and how you can ask questions about these points, lines, and polygons in the vector data model. So I want to thank you for making it through this now, Module 4 of the course, and I want you to please always remember, if it makes a difference where, geography matters. So I'll see you next week.